For example 6, part B, we are going to find the coterminal angles of negative pi over 4. So when it's in radians, we are once again adding and subtracting 2 pi. So I'm going to add or subtract, instead of writing 2 pi, I'm going to write what's equivalent to 2 pi, but being over 4. So really, in order to find that, it's 2 pi times 4 over 4, because technically that's equivalent to 1. And 2 pi is technically over 1. If I multiply those together, I get 8 pi over 4. So I'm adding or subtracting 8 pi over 4. Let's start with finding a positive coterminal angle. That's negative 7 pi over 4 plus 8 pi over 4. That was enough to get me from being negative to positive, because that's a positive 1 pi over 4. A negative we would get by subtracting 8 pi over 4. So if you subtract negative 8 from negative 7, that should give you a negative 15 pi over 4. Okay, last one. We have 3 pi over 2. So we're adding or subtracting 2 pi. But I want to rewrite the 2 pi so that it has the same denominator, meaning I have to multiply by 2 over 2, which means I'm adding or subtracting 4 pi over 2. I could add 4 pi over 2 to 13 pi over 2 in order to get a positive coterminal angle, which is fine. I mean, you're going to get a 17 pi over 2. I wouldn't waste my time, though. What I would do is start subtracting, because we're going to have to subtract continuously until we get it to a negative. And you saw that with degrees as well. So I'm starting with 13 pi over 2, and I'm going to subtract 4 pi over 2. So 13 minus 4 gives me 9 pi over 2. That's still way bigger than 4 pi over 2. So when I subtract that, I'm still not going to have a negative coterminal angle. So I'm going to go ahead and subtract 4 pi over 2 for a second time, which means I'm going to look at the 9 and just do 9 minus 4. 9 minus 4 is 5, so that's 5 pi over 2. If I were to subtract 4 pi over 2 again, I'm still not going to be negative. It's going to be another positive coterminal angle. So we are now subtracting for the third time. 5 minus 4 gives me a 1 pi over 2. We are finally at the point where if we subtract if we subtract 4 pi over 2, once again, we will get a negative coterminal angle. So this is the fourth time that we are subtracting. 1 minus 4 is negative 3. So negative 3 pi over 2 is the negative coterminal angle. And really, all of these are positive coterminal angles. Next, we have reference angles. Reference angles in degrees, you had different rules. I'm going to go ahead and remind you because we have the time and it doesn't hurt at all. If you're doing degrees, if it's in quadrant 1, theta prime, that's the notation for a reference angle, is equal to theta. If it's in quadrant 2, theta prime is equivalent to 180 minus theta, because here's 180, a straight line, and we're going to have to subtract whatever theta was in order to get the section we want. If it's in quadrant 3, theta prime is theta minus 180, because theta is bigger than 180 degrees. It's bigger than the straight line. So all of this would be gone, and then we'd be left with whatever section's here. If it's in quadrant 4, theta prime is 360 minus theta. So a full rotation minus theta gives us the little section that we want. That's all in the task 1 video if you need to go back and rewatch that. It's titled 10.2 day 1. Again, that's if you want to go back and rewatch that. I feel like radians is easier because whenever we have a radian, theta prime is just going to be pi over whatever number's in the denominator. So I want you to write that. Theta prime is just pi over whatever number's in the denominator, as long as theta is simplified all the way. That's important. So hopefully you have that written down now. And we're just going to start listing theta prime. Super easy. If theta is pi over 6, theta prime is pi over 6. If theta is 7 pi over 3, theta prime is pi over 3. Because it's always just 1 pi over the denominator. So 7 pi over 3 has a reference angle of pi over 3. If theta is 9 pi over 4, then theta prime is going to be 1 pi over 4. So all of these were already simplified. Had I given you, let's just say 4 pi over 8, this is not a simplified ratio, so you would have to clean it up and say that theta is pi over 2, and then theta prime would be pi over 2. Okay, the last thing we need to talk about is how to do conversions between degrees and radians, and it's actually a lot simpler than you would think. So if I'm going from degrees to radians, we're going to multiply by pi radians over 180 degrees. If we're going from radians to degrees, we're going to multiply by 180 over pi radians. So it's essentially the same thing, but flip-flopped. And the whole point is to cancel out your labels. This is very similar to stoichiometry, if you've done that in chemistry yet. So if I'm starting with 60 degrees, and I want to convert this to radians. So I'm going from degrees to radians. I need to multiply by pi radians over 180 degrees. Which technically, might I point out, is equivalent to 1. So we're not changing the value because pi is 180. Something over itself is 1. We can see that in the unit circle. I think I still have it over here. Yes. Pi and 180. It's the same thing. Okay. Now, by having this set up, I want you to notice that your degrees will cancel out because I have a degree unit in the numerator and a degree unit in the denominator. And when we multiply fractions, remember we go across the top, across the bottom. So this is technically 60 over 1 if you want to put that there. So 60 pi radians over 180. 60 over 180, I want you to see that that too simplifies. 60 over 180 becomes 1/3. So really we have 1 pi over 3, or just pi over 3 radians. You could write radians, you could put rad, whatever you want to do. Part B. Now we're going to convert from pi over 4 radians to degrees. Make sure you write pi over 4 radians. That way we can have stuff cancel out. And I'm going to multiply by, we could see radian to degree, we do 180 over pi radians. And this time, not only do the units radians cancel, but so do the pi's. So I'm just left with 180 degrees over 4. Let me scooch that over so you can see. 180 degrees over 4. And that does simplify further. That gives me 45 degrees. Something that I want you to make a note of. Note. We just said that 60 is equal to pi over 3 radians. We discovered that pi over 4 radians is equal to 45 degrees. Let's look at the unit circle. 60 is pi over 3. You should already know that. Pi over 4 is 45 degrees. The only thing I didn't list is that 30 degrees is pi over 6. So let's go ahead and make a note at the very end. 30 degrees is pi over 6 radians.